Hello everyone, let's go ahead and do our experiment 9b pre-lab questions. It's not that hard, it's just acid-base pH concentrations of acids and the bases and pH of the solution is what we are going to learn in this section. Okay, so the first one, the concentration of hydronium ion, which is H3O plus, in a solution that contains a weak acid is 5.28 into 10 to the negative 5 molar. What is the pH of the solution? So a strong acid, if you take a strong acid, it would completely dissociate into give you ions, right? For a strong acid, it would dissociate to give you, for example, HCl is a strong acid. It would completely dissociate to give you hydrogen ions and the chloride ions and 1-to-1 ratio. And in fact, in an aqueous solution, you would not find any hydrochloric acid intact as HCl. It would be 100% H plus and 100% chloride ions. For example, if you start with 1 molar solution, your H plus would be 1 molar, chloride would be also 1 molar. But it's different for a weak acid. Weak acid, as the name says, it's a weak electrolyte in the sense it would not dissociate 100%. For example, if you take HA as a weak acid, it would give you, it's a reversible reaction, H plus and Cl, not Cl, it's A minus. Okay, and also we can represent this as equilibrium, and even in the equilibrium we can represent in like this, because the forward and the backward reactions are not up to the same amount. Okay, now we know any acid, either it's going to be a weak acid or a strong acid, it's not going to exist by itself as HA. We always write it in the form of HA plus water. What's happening with the water? HA plus water. So then we have HA is going to be your acid, water is the base, not the base as to say, but it's a solvent, but it would exist hydrogen ions as hydronium ions. Water molecule has these lone pairs. It'll go and take this hydrogen and form hydronium ion, and then you have the conjugate base of the acid, A minus. So that's why you would see hydronium ion concentration is written in place of H plus. Okay, so this is a weak acid, and the concentration of hydronium ions are given as 5.28 into 10 to the negative 5. What is the pH of the solution? It's easy, right? So we can find out the pH of the solution with this form. pH equals negative log of H3O plus. So negative log hydronium ions 5.28 into 10 to the negative 5. So you take the negative log of this, I put the numbers in the calculator, and you will get the answer, and write the answer in 2 decimal places. Okay, so you guys can write it down over here. I'm not going to give you the answer, you guys can do it. Okay, question number 2. The concentration of hydroxide in a solution that contains a base is 0.268. What is the pH of the solution? So we are given the hydroxide concentration. So we can find out the pOH from the given hydroxide ion concentration. So the pOH is going to be negative log of hydroxide ions equals negative log 0.268. So you take that. That's going to be the pOH. But what do we want? pOH or pH? We want the pH. So how do you calculate the pH if you know the pOH? pH plus pOH. In water medium, when you add up the pH and the pOH, it's always going to equal to 14. So when you find pOH from here And then let me go ahead and give you what is POH. That's going to be 0.572. 572. Do this calculation and see if you also get the same answer. So then the pH going to be then, so pH going to be 14 minus 0.572. And again, answer in two decimal places, 14 minus 0.572. You can put that answer right there for question 2. And to answer question 3 through 7, consider a situation in which 25 milliliters of hydrochloric acid, which is a strong acid, titrated with sodium hydroxide, a strong base. So HCl plus NaOH, strong acid, strong base titration. What are the products we're going to make? What are the two products? It's going to be sodium chloride and water. And it is a 1-to-1 reaction, meaning 1 mole of hydrochloric acid will react with 1 mole of sodium hydroxide. Okay. So 25 milliliters. Suppose that the initial pH of the solution, acid solution, before any base is added is measured to be 1.02 is the initial pH. What is the hydronium concentration of in moles per liters in the start of this titration? So we are given the pH. Now we want to calculate the hydronium ion concentration. Again, we can use pH equals negative log hydronium ion concentration. We given 1.02 equals negative log H3O plus. So how do you calculate the hydronium ion concentration? H3O plus would be then anti-log, or you can type in log 10 negative 1.02, anti-log of negative 1.02 hydronium ion concentration. H3O plus would be shift log and then negative 1.02 in your calculator. Okay, you should get a smaller number because it is acidic medium. Okay, should be a number less than 1. Okay, you guys can get the answer for that. And then the next one, how many millimoles are in the acid solution at the beginning of the titration before any base is added? Now, once you find out the hydronium ion concentration, you're going to find out the millimoles. So from your answer to question 3, you're going to find out the molarity, which is the hydronium ions. And what's the volume? Volume is going to be 25 milliliters from the question 1. So now you know the volume, also you know the concentration, which is molarity. Can you find the moles now and then convert to millimoles? Yes, you can, right? Well, I'll go ahead and do it here, but you don't have to follow my calculations. You can do your own. Okay. So I have to give you the answer for question 3 then. Okay. So the moles are going to be molarity times the volume. So the molarity is the answer you're going to get for question number 3. Okay. Well, I got the answer 0.0955, but make sure you also get the same answer, which is the answer from here. Okay, 0.0955, that's moles per liters. And then the volume is 25 milliliters. We need to convert to liters. And what we want is the millimoles. Millimoles. How do you convert moles to millimoles? How many millimoles are in 1 mole? So 1 mole has 10 to the power 3 millimoles. So basically these two can get cancelled. Right? You multiply then 0.0955 into 25 to find out the number of millimoles. Okay? Something like this, 2.3875. millimoles. Again, I'm not sure if my answers are correct. You guys want to check to see if they are correct. Okay. Question 5. The titration curve for the strong acid strong base titration is provided on the first page of the titration curve of pre-lab assignment handout, which is also given here. This one right there. This one. Okay, you can find it in your Blackboard site. When you click here under question 5, it will show you the titration curve. So don't worry about the pre-lab handout, which is already attached here. Based on this titration curve, what is the pH of the at the equivalence point of the titration? Okay, so this is the titration curve. Now this is a strong acid strong base titration curve, and underneath you find a weak base strong acid titration curve for some of the other questions. Now how do you find out the equivalence point? Okay, so you can see here the midpoint. I will have to download this, I believe, so I can write on it. Okay, now you see this is a strong acid strong base titration curve, and we want to find out what is the equivalence point. So our strong acid, we start here, strong acid around pH 1, and then you keep on adding your base. The volume of the base will be on your x-axis over here, and as you keep on adding, so you can see here it reaches around 22, volume 22. You can see a sudden increase of the pH. We are still here at the pH between 2 and 3, and then a sudden pH increase goes all the way to 11, very basic. So between here is going to be our equivalence point. So you take the midsection between these two, somewhere here, right? It's a strong acid strong base titration. So basically the equivalence point or the end point reaches at exactly pH 7. So this is where the midpoint. So the equivalence point or the end point will be at pH equals 7. And then you also need to find out what is the volume of the base added to reach the end point. How do you find that? So you reach the pH 7 and then you draw a line directly to find out where are you going to end up, or where you going to meet the x-axis. So in one of the other questions, that is, what is the volume of the base added to reach the end point? So then you take the pH 7 and then draw a line, cross the x-axis, and then you read that as the volume. So that is something somewhere like 20, 21, 22, 22, it's before 23. So maybe somewhere around 22.7. And if you want to add another significant figure, because it goes up to 4 significant figures, 22.75 or something like that. Okay, that's the volume of sodium hydroxide needed, and then the pH would be 7. Okay. And let's go back here. So the question, use a strong acid strong base titration to estimate the volume added. And then question 5, based on this titration curve, what's the pH at the equivalent point? pH, we found the pH, so you're going to write down it here. Okay, and then estimate the volume added based in the volume added base required to reach the equivalence point. Again, I showed you how to calculate that, so you're going to write down that answer here. let's say about 22.78 or 75, or so you can, sometimes it would be helpful for you to print this out and get the answer. So it could be 22.75 or something like that. Okay, and then write down the pH there, and then use your answer to question 4 and 6 to calculate the molarity of the sodium hydroxide solution. So we found out the volume of the sodium hydroxide, and this is a strong acid strong base titration, and then the molar ratios are 1 to 1 according to the balanced equation. So we know the volume in milliliters, and also we know the number of moles. Remember, we calculated number of moles of hydrochloric acid. Since this is a strong acid strong base titration, according to the equation, number of moles of hydrochloric acid is equal to the number of moles of sodium hydroxide, right? So then the amount of sodium hydroxide in terms of millimoles also going to be 2.3875, and we know the volume 22.75, so we can find out the molarity of the sodium hydroxide solution, which you guys can do. Molarity equals moles over volume. Moles are given in millimoles, 2.3875. 2.3875, those are your millimoles, and you divide it by the volume that you estimated from the graph, 22.75. You need to convert it to liters, 10 to the negative 3 liters. Again, this is millimoles. How do you convert millimoles to moles? How do you convert millimoles to moles? 10 to the power 3 millimoles equals 1 mole. This can get cancelled. 10 to the negative 3, 10 to the positive 3. So 2.3875 over 22.75 will give you the answer, which is going to be the molarity of your sodium hydroxide. Okay? Yeah, so you can write that down in question 7. And then the question 8, 8 through 10, consider a situation where 25 milliliter ammonia. Now we're gonna look at a weak base and a strong acid, nitric acid. You will need to refer to the weak base strong acid titration curve, which is attached here. Estimate the initial pH of the base solution before any acid is added. Now let's look at the titration curve over here. Okay, so this is a weak acid and strong base titration curve. What is the initial pH? Is that going to be initial pH? Is it going to be somewhere here, somewhere here, or somewhere here? Which one is the initial pH before we add anything to this one? We start with a weak base. So if it is a weak base ammonia, pH has to be more than 7. We haven't added any acid yet, so the initial pH is going to be somewhere here. So you can estimate that. Okay, you can estimate. So this is going to be 11, and then the midpoint going to be 11.5, and then the next one 11.6, but it's going to be between 11.5 and 11.6. 1, 2, 3, 4, 5. Oh, this is 10. Sorry, I was looking at this as 10, 11. Okay, so then if it is 10, so the 11 is going to be the midpoint right there, 11. After 11 comes 11.2, 11.4, 11.6, 11.8, and 12. So before 11.2, So before 11, between 11 and 11.2. Maybe you can say 11.1. It's not 11.2, 11.1514, something like that. Okay, so here you're going to estimate that, and you can say 11.1 and then estimate the other number, because you have to put it in 4 decimal places. 11 point, maybe you can say 14 or 15, 13, 16, something like that. Okay, that's the initial pH. Also, you need to calculate the equivalence point. That's going to be another question that you need to answer. What is the end point? Where is the end point? So what's happening in this titration curve? You start with a higher pH and then you keep on adding your hydrochloric acid. As you add hydrochloric acid from here, you will see the pH is going to suddenly drop from around pH 8 to pH 2. So between here and here we find the midpoint and find out what's going to be the equivalence point. So you take the midpoint, mid section between these two lines must be somewhere here, and then draw a straight line. This, my line is not going to be straight, but you guys can draw a straight line and find out what is the volume of hydrochloric acid that needs to be added to reach the end point. Something like, let's say 25, 26, 27 and 28. It's after 28, before 29, something like 28 point, you can say 28 point, if it is 28.2, 28.20, or it could be 28.16 or 28.14, some number that you would estimate by drawing a straight line from the midpoint to the x-axis. You will find the volume of nitric acid added to reach the equivalence point. Okay, and here is the initial pH, and you will estimate the volume of nitric acid added to reach the end point. Okay, estimate the pH. I showed you how to do that, and then titration curve, estimate the pH at the equivalence point. We didn't do that. Let's go back and do that. And then the question 10, use the estimate the volume of added acid. I showed you how to find the volume of the acid added, okay, by drawing a line to the x-axis, but I forgot to show you how to calculate the equivalence point. Let's do that over here. Okay, so the equivalence, did I tell you about the equivalence? Well, maybe I did. Between these two lines, you find it, maybe it's going to be somewhere here, right? Between 4 and 6, somewhere there. Okay, so 4 point, not 4 point, 5 point something. That could be 5.25 equivalence point or 5.27, something like that. Okay, that's how you find the equivalence point, the initial pH, and then the volume needed to reach the end point from a titration curve. Okay, I think that's about it. So all the questions are answered now. You can do your pre-lab. Okay then, all done. I'll talk to you soon. Bye.